Hello and welcome to our Cognition Part 1 notes. Our cognition and memory units are combined. They're both considered Unit 7, but it's considered A and B. We learn about memory and how we construct memories first, and now we're going to talk about what we actually do with those memories or how they're organized in our brains, and that's called cognition, and we'll define that here in just a second. But in our cognition unit, I'm going to go back just a slide, we're going to be looking at the idea of thinking, problem solving, creativity, and then language. Because language is this kind of overlap of all these things and how we communicate. In these notes, we're going to look at just a few different things. What I did, or what you did last week in school, is when you did your SQ3R, I had you outline just this chapter or just this portion and then make the headings into questions. Here are some questions that I came up with. So if you look at your chapter 10 preview, the SQ3R, here are some things that I looked at the headings and I thought these were good questions. So we're going to learn about concepts. What are the functions of a concept? Why do our brains make concepts? That's the question I came up with, or from your book. What strategies assist our problem solving? So we're reading about problem solving. What are some things that we can do or strategies that we can implement to assist our problem solving? What is creativity and what fosters it? So if we have a section on creativity, what exactly does that mean to be creative? How do we say one person is more creative than another? And what fosters it, which means what brings it to life? Okay, now the rest of the unit, so you'll have notes on thinking, language, and then the two put together. All right, so you don't need to write this down. That's just kind of a preview of what's coming up. So let's actually start talking about thinking and cognition. So I want you to think those things together. So thinking when you think cognition. The definition of cognition here, though, no yellow box, here it is any mental activity that's associated with thinking, knowing, remembering, and communicating. Cognition, any mental activity, so a cognitive task that's associated or linked together with thinking, so not necessarily saying, but your thoughts, knowing, so being able to identify, to be able to recall, remembering, so memories are cognitive tasks, and then communicating, so whether that's language, but somehow communicating your thoughts is going to be considered cognition. Cognitive psychologist would be any person who deals with those things, thinking, knowing, remembering, communicating. All right, so any one of those four categories would fall under a cognitive psychologist. Cognitive thinking. Okay, so let's start off with what is thinking, right? So if we're going to define cognition as thinking, we're going to start with talking about our concepts, then our imagination, and problem solving. So the first thing we'll talk about is a concept. You've probably heard this word a lot in school, in your classes. But a concept, when we talk about the concept of anger, the concept of a triangle, it's a mental grouping of similar objects, events, ideas, or people. A mental grouping of similar objects, events, ideas, or people. So when you have the concept of an object, so a chair, all right? So you might have a picture of a chair in your mind, or you might be seeing something like this, but a chair can also encompass like a baby chair, I want to say a high chair, a dentist chair. You kind of group all those things into defining that a chair is a thing that you can sit in. All right, so that might be your concept of a chair. If it's a concept of an event, a party, right? So like a party might be a birthday party or a homecoming party, or like, so it's a concept of people getting together and celebrating, right? So that's the concept of a party. An idea like anger or happiness, what you think that might mean, and then people. So your mental grouping of certain people. Now there are category hierarchies, meaning that like there's an order to the way we categorize different concepts. So a prototype would be like the typical description of that concept. So the prototype, think of like the typical description of that concept. So if you were to look at these two pictures here, this is a penguin and this is a robin. These are both birds. So if I asked you what this is, it's a bird. Penguin's a bird. A robin's a bird. But when asked which one is more bird-like, people are more likely to say that a robin is more bird-like. It's birdier than a penguin. It literally says that in your book. I didn't make it up. Birdier than a penguin, because a robin fits the prototype in your mind of a bird, that a bird has 2 feet, it has wings, it's able to fly, right? That might be your prototype of the bird. Even though that you know a penguin is a bird, it has 2 feet, a wing, it's not able to fly. It doesn't quite fit the prototype or like the perfect description that you have of a concept. Okay, so a prototype is like that perfect description of a concept. It doesn't necessarily mean that it's everything. It'll perfectly encompass it, like a penguin or maybe a flamingo, not as birdy as a robin, but it is that general description of a concept. So these prototypes can also be applied to people. I saw a lot of you looking at these pictures in your books today, so I'm going to show you the next like 6 slides and just kind of pay attention to the subtle differences about a person. All right, so here's a large man's face. It's going to change. And that scale went from being, what they did is they mixed faces, just like we talked about in our last notes, from Caucasian to Asian in different percentages. So they can actually have, like making a face of 90% one extreme, so Caucasian, 90% Asian. So here's what they found. So what they found is that once you have, as far as memory construction, once you have placed something in a category, so what they did with this study with these people, they didn't just flash these faces. They showed someone that was like 70% one way or another, Caucasian or Asian, or even the 60%. So they showed a person and then they said identify them as Caucasian or Asian. And when a person placed that person into the category, so they said that person's Caucasian or that person's Asian. When they were later asked to recall or or to point out in a picture who it was, they tended to err on the 90%. All right, so if I saw someone, or what I found in the studies is if they said that they saw someone that was Caucasian, so maybe this person here, a week later when they were asked to point to that person, they would say that it was more likely this person, right? So your brain placed that item in the category of Caucasian or Asian. Our memory of it later shifts towards the prototype or the typical description of that category. In this case, it would be the 90%. Right? So if I first saw someone that looked like this, later my memory might say that it was this person. If I first saw someone that looked like this, that tended on that more be a percentage towards Asian looking, my memory tended to shift towards this picture. Again, thinking about eyewitness accounts and who you saw or what you saw weeks later. Someone that looked somewhat male or female, that's a pretty extreme. But with looking at ethnicity, you're more likely to place them in categories later because that's where your brain prototyped or placed them under. All right, so let's look at problem solving. So we talked about prototypes and concepts, this idea of having concepts. Now let's look at problem solving. So 3 words that you're going to need to know here. Actually, hold on a second. Sorry, I want to type those things in there. It's a magical change of slides. Okay, so going to problem solving or solving problems. So here are 3 strategies and vocab words that you need to know. So how do we solve problems, things that arise? This can be something as a math problem, as a problem in your life, as grocery shopping, trying to remember what you're going to get. So any type of problem that's like presented, okay? It could be a fun problem you're trying to do, like crossword puzzles or anything like that. So there's 3 different strategies or ways to solve a problem. These 2 right here, algorithms and heuristics, are going to be strategy based. Insight is more of a sudden type of realization. It's not as much a strategy. So an algorithm. And this is more of a tedious step-by-step process that guarantees a solution. Okay, so an algorithm, you may or not be familiar with this from math. It's a step-by-step procedure that guarantees a solution. So I want you to be thinking about going to the store to go grocery shopping. I can't remember what I need. So an algorithm, a procedure might be is I'm going to go up and down every single aisle and look at the items until I see it and say, I need that, I don't need that. That's a step-per-step procedure that guarantees that when I leave this grocery store, I will have all the groceries that I need. Versus a heuristic. This is a simple strategy that allows us to make quicker judgments by kind of generalizing and being able to solve quicker. So heuristics, all right? So that would be me going to the front of each aisle, glancing at the sign that says down this aisle are cereals and crackers, all right? A general idea, and being able to say, yes, I I need that, or no, I don't need that. All right. So a heuristic is a simple strategy that allows us to type of like group and make judgments quicker than doing an algorithm solving step by step. And the third type of solving problems is called insight. We've talked about insight. I don't remember. I think during memory. Haha, didn't remember. I didn't retrieve that fast enough. So an insight is a sudden realization of something. There's no strategy to it. You're trying to like unscramble letters. Maybe we'll do this in class where you unscramble letters to make a word, and you're kind of looking at the letters, waiting for them to make sense, and it just pops into your brain like, oh, it says camel. Right, so you're unscrambling letters. There is no type of procedure you're trying to follow. It's that sudden insight to the answer of a problem. So this totally contrasts strategy bases of algorithms and heuristics. Now, what people have found, or brain researchers have found, and you probably need to know this, is that that insight that tends to happen, they had people solving those type of puzzles where you're unscrambling words. The brain activity tends to be located in the right temporal lobe. Those are the sudden burst of energy. So when we talked about what our lobes do, our left and our right, we talked about languages in our left. A lot of our problem solving and higher order thinking of brain, what I'm going to say, structures are located in our right brain, so our right temporal lobe. That's where they found, looking at EKGs and fMRIs, that there's a sudden burst of energy. Okay, so that is problem solving. Next, we're going to talk about, just kidding, I can't change the slide. Solving problems using creativity. Okay, so we talked about what exactly is creativity. So creativity is the production of a novel, new, and also useful idea. Production of a novel and useful idea. Okay, so that is what the term of creativity means. Now, people who are generally mathematicians, architects, artists who are considered creative, coming up with new types of things that are useful, aren't necessarily shown to be more intelligent than their peers, but they do tend to have these different components of creativity. Let me go back to creativity. You need to know that creativity requires, or is much better if people have divergent thinking, meaning that instead of coming to one possible only answer, divergent, it goes away from the problem, right? So going to many different solutions, divergent thinking, going away from. So creativity requires divergent thinking. So Sternberg, this is a psychologist who did a study about people who are considered creative, so new ideas that are useful, found 5 components of creativity that you need to know. First of all, for someone to be creative in their area, they need to have expertise, meaning that if I'm an architect, they need to have knowledge about buildings. If you're an artist, you need to have knowledge about how paints come together. So there's a certain component of, even though like you could have this great idea, you need to be of an expert in that field to have, if you really understand how things are working, you're more likely to have that divergent thinking, to think outside the box. Okay, so creativity. What is 100 things you could do with a brick? Right? So that's asking someone to be creative. So an imaginative thinking, being able to imagine something being that it's not. All right? So visualizing something like that brick being a doorstop, or brick being used to build things, to cover up things, right? So using your imagination or visualizing things that aren't real to be creative. A venturesome personality, people who are kind of willing to take chances, are willing to be wrong. Most people who are creative have failed a lot of times, but they have a personality that's not held back by that. An intrinsic motivation. Remember, a long time ago we talked about intrinsic versus extrinsic motivation. A personal need to want to do things to make them happy. This was in learning, so reinforcing behavior. If you have an intrinsic motivation, it's better than an extrinsic, being motivated by external things like money or fame. And then having a creative environment, being somewhere that allows you to be creative, being around other people who inspire you, is something that inspires creativity. Okay, so that's going to be the end of these notes. In our next notes, we're going to talk about some obstacles that come from solving problems, so things that get in the way. And then later we'll be talking about more about language. Okay, have a good day.